I'm Tom Witherspoon, and I am recognized as a diplomate by the Geo-Institute as a geotechnical engineer, and I'm recognized by the Structural Engineering Certification Board as a structural engineer. I have a BS in civil engineering, a master's in business. I have a PhD in geotechnical engineering from the University of Texas at Arlington, and my dissertation studies was Piering and Piling, so that I know pretty well. And in my 22 plus years as owner of S&W Foundation, did a lot of limited access drilling, and so I know the contracting side of it as well as the engineering side of it. For the past 13 years, I have operated only as a engineering consultant. I sold S&W to David Bowman back in March of 2008, and since that time have just done consulting work. But you know, at one time when I first got out of college with my BS in civil engineering covered civil work such as dams, reservoirs, things like that. Geotechnical engineering, which was the soil analysis, and structural engineering, which was everything from the ground up. And it's hard for me, I guess that's the reason why that I've got both designations and even do some civil work, is because it's hard for me to differentiate because they all tie in together. Now, structural engineering is from the ground up. I mean, you've got to take what the geotech has given you, and you have to have enough knowledge about structural engineering to apply it to your structure, because you've got to know what kind of structural underpinning in some cases is going to have to be established under this structure to make it work. So you have to have some knowledge of geotechnical engineering, and you have to establish, given the things from the geotech, all of the parameters, you have to establish if you're going to do drill piers or auger cast piles, you have to establish that termination stratum, or if you're going to bell at a depth below the active zone, which is the active zone is the zone of seasonal moisture change. You have to establish what the underpinning, the piering or piling, is going to be for that. And you're going to have to, if you're in an expansive clay area, you have to establish how much reinforcing steel is going to be required, the diameter of the pier, the reinforcing steel required for that pier, and in all cases you have to have some kind of centralizers to keep that reinforcing steel in the center of that pier, because it has to be at least 3 inches from the side of every pier inside. If it's an auger cast pile, there's 1 bar down the center, but at the top you're going to have a cage that has to be kept within those parameters, and your center bar on an auger cast pile has to remain centered in that pile. So there's going to be certain factors for uplift. There's going to be compressive loading from the structure. You have to establish then that you have sufficient skin friction and or end bearing to support that structure. And the geotechnical report is also going to establish what the water depths are. What depth are we going to encounter water, because that is going to establish whether it's a drill pier with casing or whether it's an auger cast pile that's drilled right through it, and by that process the grout pushes up the water and makes a competent shaft or pile in that area. You have to know that, because that's going to establish what type of underpinning is going to be required. You also may have eccentric loading. With a drill shaft or with an auger cast pile, there may be certain parameters that you have to miss, and you have to have that a haunch at the top for eccentric loading, and then there has to be sufficient reinforcing steel centralized in that shaft so that it accepts that and transmit it down the shaft itself. In cases of remedial underpinning, then you're going to have a haunch in almost every case. There will be a haunch under the side, under that perimeter grade beam or that perimeter structure, and there's going to be a haunch that has to establish that, and there has to be sufficient reinforcing steel in that to transmit that down the shaft to the bottom. And so you have both lateral and bending moments that you have to establish the reinforcing steel. And if you're on a slope, then you have to, in many cases, realize that you have to penetrate certain faults or fissures to prevent a global failure of that hillside. And I normally come in after the fact, after it's failed. And then I have to figure out, with geotechnical studies, have to figure out exactly what's down below there and what are we going to have to intersect. How big a diameter a shaft that we'll have is sometimes a product of depth, because the deeper you go, the bigger diameter of that shaft and the more reinforcing steel that you have. I've learned a lot from others' mistakes. I've been doing my best to stay out of the courtroom in a defensive posture. And so I want to be working for the attorney that's prosecuting and not on the receiving end. So you learn over time, you learn from others' mistakes. Hopefully you learn that, because life is just a series of landmines and you want to avoid those as much as possible. In cases of remedial piering, you can use micropiles. In some cases, you can use auger cast piles, but in most cases, it's going to be a drill shaft or a micropile. There is a building in, I think it's San Francisco, that is leaning now. And they didn't do a proper geotechnical study as deep as they should. And you've got a combination of earthquakes and other factors that you need to design for. And this takes a whole different set of engineering, because you have to intersect those faults, because when you have an earthquake, you have liquefaction of that material because of water tables and everything, and it'll completely destroy anything that is not properly designed. One of the reasons for having a centralizer for the reinforcing steel, and it's been established to keep it at least 3 inches away from the perimeter of that shaft. Now in some cases it'll be they wanted a little more, but for most cases at least 3 inches, because you want to prevent the water from getting to the reinforcing steel. If it gets to the reinforcing steel, the corrosion of that steel will blow out the pier. It'll destroy the integrity of that pier, because you've got the reinforcing steel is for tension. Concrete is great in compression, but it's not very good in tension, and you have deflection of a drill shaft that you're trying to prevent with those centralizers. It's very important when drilling a pier or an auger cast pile that the driller makes sure that, I mean, if it's an open shaft, the driller can drill it, and the inspector will test it to make sure it's plumb, because it has to be within a few degrees of plumb, or you lose the effect of that structure. That underpinning cannot be that far out of alignment, or then you've got other factors that play into it that would cause a problem. With an auger cast pile, in many cases, a competent inspector that's normally supplied by the geotechnical firm will actually sit up there on the rig and watch the instrumentation to make sure that this, in drilling this that you can't see, and you can't check after it's over, see if it's out of alignment, because the equipment is so specialized now, so computerized, that you can tell any kind of deviation of that pile. So it's extremely important that all of that be centralized and that the shaft be plumb. One of the things that's very important for any structural engineer is to have complete specifications, because if you don't specify it, the contractor's not going to do it. They're going to do the cheapest thing. And the best protection a structural engineer can have is a complete set of specifications to tie down that contractor to what has to be done. And in most cases, like in piers or piles, it is critical for the geotechnical engineer to inspect each one of those shafts or piles to make sure that it's properly done. Because if the foundation is messed up, the problems are going to last for an eternity. I mean, as long as that building's in place, there will be constant problems. And it's very important to specify centralizers for the reinforcing steel, because if you don't specify it, the contractor is not going to do it. And the greatest protection that a structural engineer can have is complete specifications, tying it down and demanding these things. Now, I know a lot of engineers that get pressured, arms twisted by the client don't put all that in there. But if you do that, you're making yourself a target. Any structural engineer is a target anyway. Why go ahead and give them the bows and the arrows to shoot at you? Because you are a target. The best thing you can do is stand your ground and make sure that all the specs are completely competent. When I was on S&W Foundation, we used peer research for our products, and they were the ones that we purchased from, because I knew that the product was going to be competent and take care of us. Make sure that you're specifying centralizers for the pier or the pile so that you keep the reinforcing steel where it's supposed to be, so we don't have corrosion on the side that eliminates the tensile strength of the steel, which is its purpose, and to make sure that your specifications are completely adhered to. You had to make sure of that.
This video was made courtesy of Peer Research, the standard of excellence, manufacturer of high-quality alignment and centralizer products for the deep foundation and earth retention industries.